I'm going to talk about visions or visual hallucinations, which is the situation where somebody sees something that isn't objectively there. At first glance, this is something very mysterious and difficult to comprehend, but actually when we examine the visual system, we see that it's continually creating images and, in some senses, producing its own visions. My name's Paul Fletcher. I'm a professor of psychiatry and professor of health neuroscience at Cambridge University.
So, good evening. Good evening and welcome to the first of the 2019 Darwin College Lectures here in Cambridge. This is the 34th series of these lectures. And this year the theme is vision. So vision, eyesight, detecting photons, the mind's vision, a design, a process, a plan for the future. Seeing, is that reality? A dream? A hallucination? A foreseeing? A prophecy? Salvador Dali's painting Dream of the Cosmos, inspired by St. John of the Cross's vision. And sometimes visions are dangerous. Opposing visions create division. What is unforeseen can be disruptive. Vision is such a wide concept. Where would we be without it? Our task is to look and to have vision. So the most pathetic person in the world is someone who has sight, but no vision. So said the blind visionary Helen Keller. Or, where there is no vision, the people perish. That's Proverbs 29:18. That's really all why universities are not just training institutes. Without vision, we fail. So, our 8 distinguished speakers from across the arts, sciences, and humanities will take us across the whole spectrum of vision, from capturing photons with our own eyes to a not-too-distant future where the deepest visions may be those seen by artificial intelligences. How did life travel from light detection by a jellyfish to using telescopes to map the universe? But tonight, for the first lecture, we start with in the mind, for without our minds, there's no vision. How does the brain see? How does our mind make a model of what surrounds us? How do we actually perceive the world in which we live, we survive? And crucially, what is reality? So tonight, to answer such questions, please welcome Professor Paul Fletcher, the Bernard Wolfe Professor of Health Neurosciences here in Cambridge. Paul studies human perception, learning and decision-making, as well as hallucinations, and he will speak on visions. Paul, welcome.
Thank you all for coming. Thank you to the Masters and Fellows of Darwin for this tremendous honour. And thank you too, of course, to my employers and funders and to a couple of very special collaborators to whom I'll come in a moment. Oh, I did just do that, yeah. It's also important to acknowledge that I don't work in a vacuum. I've been very fortunate in my current and recent collaborators. I don't have time to tell you their contributions here, but they should know that I deeply value their inspiration and their thoughts, and many of their ideas you'll see wrapped up in this lecture. In 1837, in Chapter 3 of the posthumous papers of the Pickwick Club, Jem relates to Mr. Pickwick, the sorry tale of his actor friend whom he had visited on what turned out to be his deathbed. The man was clearly dying of delirium tremens and was visited by horrible apparitions. There were insects too, hideous crawling things with eyes that stared upon him and filled the very air around, glistening horribly amidst the thick darkness of the place. The walls and ceilings were alive with reptiles, the vault expanded to an enormous size, frightful figures flitted to and fro, and the faces of men he knew peered out from among them. Writing some 40 years later in L'Assommoir, Émile Zola describes Coupeau, the husband of the novel's heroine, Gervaise, when she visits him in a Paris sanitarium. Coupeau has been drinking very heavily of absinthe, and he too is going through withdrawal symptoms. He was seeing spiders' webs all over the walls as big as ship sails, then the webs turned into nets with meshes that got larger and smaller. Black balls popped in and out of the meshes, sometimes the size of marbles, sometimes big as cannonballs. The balls were turning into rats, the filthy beasts swelled up and then vanished. And there was a monkey too, coming so near him that he jumped back for fear of having his nose bitten off. The First World War poet Siegfried Sassoon was so traumatized by his experiences in the trenches that he experienced visions for many years afterwards. In her brilliant trilogy, Regeneration trilogy, Pat Barker begins by describing an imagined conversation between Siegfried Sassoon and the psychiatrist William Rivers. When I woke up, the nightmares didn't always stop, so I used to see corpses, men with half their faces shot off, crawling across the floor. The pavement was covered in corpses, old ones, new ones, black, green, his mouth twisted. People were treading on their faces. Sassoon served too as the inspiration for Septimus Smith in Virginia Dalloway's novel, Virginia Woolf's novel, Mrs. Dalloway, published in 1925. Septimus sees visions in broad daylight, and these include the reawakening of his dead friend who died in the trenches. The elm trees beckoned, leaves were alive, trees were alive, and the leaves were connected by millions of fibers with his own body. There was his hand, there the dead, white things were assembling behind the railings opposite, but he dared not look. Evans was behind the railings. All of these authors were assiduous researchers. Pat Barker, in the bottom left, Charles Dickens, Émile Zola, and Virginia Woolf. Virginia Woolf, moreover, was able to call upon her own experiences in describing the character of Septimus Smith. Smith hears the birds harmonizing to him in Greek, which was an experience that Virginia Woolf had had during one of her own, what was referred to as mental breakdowns. As well as giving us very powerful, very beautiful descriptions of these horrendous apparitions, what these passages really show us is the degree and profundity with which the human mind can create images of what is not objectively there. And it poses, too, the sort of challenge that I, as a neurobiologically orientated psychiatrist, must face in trying to come up with some comprehensive understanding of these complex phenomena. Now, of course, it might seem paradoxical that we begin a lecture series on vision with a consideration of what is clearly a profound aberration in vision. But I think and I hope that as the lecture goes on, you'll agree with me that we can learn a huge amount about the nature of vision from looking at this peculiar aberration. I propose to come up with one conclusion to this lecture, and I'll tell you what it is at the beginning in case anyone has their attention diverted by anything. The idea is simply this. The visual system in its structure and function confers a ready-made tendency to create perceptions, to see visions. And I want to come up with that conclusion by unfolding three key ideas. The first one is that though visions are extreme and distressing at times, they're not usually associated with a severe or indeed any pathology necessarily. Secondly, visual signals are indirect. They're intense, ambiguous, and delayed, and perception as a consequence cannot be a passive reception. It has to be an active process decoding these challenging signals. The third idea is that ultimately to perceive, we're engaging in an act of inference that's concocted of two key processes, what we expect and what we're getting. This entails a very powerful but ultimately quite perilous way of apprehending the world. So with those three ideas coming to one conclusion, I propose to divide this talk into three parts. In the first, I just want to survey visions. What do we mean by visions? or visual hallucinations, and the many types and circumstances. In the second part, I'm going to take a necessary but slightly apologetic detour to consider normal vision as a process of guesswork and as a balance between expectation and input. But in the third part, I'll come back to reconsider this idea against this background of knowledge and ask the question, is normal vision hallucinatory, and what are the vulnerabilities in the system? The first part really concludes with the idea that visual hallucinations have many forms and causes, and they're not always pathological. One person who was visited by visions quite frequently was the science fiction writer Philip K. Dick. Really, the whole corpus of his writing was about the question of what is reality and how do we know about it. And he experienced phenomena such as this. One day, walking down the country road to my shack, looking forward to 8 hours of writing in total isolation from all other humans, I looked up in the sky and saw a face. It was a vast visage of perfect evil. It was immense. It filled a quarter of the sky. It had empty slots for eyes. It was metal and cruel, and worst of all, it was God. Philip K. Dick did confer with a local preacher whose opinion was that it was probably Satan and not God. It remains disputed to this day. Dick, as this, many of Philip K. Dick's novels are really about people tussling with reality and living within a hallucinated creative world, the sort of world in which one becomes an unshared reality, one in which they're immersed and invested. But it's not always the case that the visions that we see, including in what would be formally defined as psychiatric illness, are necessarily completely overtaking someone's perspective or apprehension of the world. And in the 1960s, a couple of very careful papers detailed in the first person verbatim the actual experiences of individuals, and a lot of these were not about full-blown hallucinations, but rather about distortions in perception, distortions in vision, of the following sort. So I feel that everything is coming towards me, I see things more than what they really are, everything's brighter, louder, noisier. Or when I start walking, I get a fast series of pictures in front of me. Everything seems to change and revolve around me. Something goes wrong with my eyes and I've got to stop and stand still. Everything I see is split up. It's a bit like a photograph that's torn in bits and put back together again. Now, about 4 years ago, I was very fortunate being contacted by a local video game design studio called Ninja Theory. And they had the desire to represent some of the phenomena of psychosis, the voices and visions of mental illness, within the context of a game. Talking to them, it was very clear that they were sincere in treating this respectfully and honestly. And quickly, we brought on board an amazing group of people from Recovery College East, people who themselves have had these experiences and who are willing to talk about them, to meet regularly, to discuss what the company were producing, and to comment on it and change it. And they very kindly made available to me a few snips of the sorts of experiences that people were describing. So I'm just going to play that to you. It takes about a minute and a half, and I think it'll be quite useful just to see it. So there were many meetings like this in which we sat around images and discussed them. So these give you a flavour of the sorts of experience that people were describing and that were being reproduced by the visual and auditory artists, because the game includes voices and things as well. And ultimately, I think they've produced an incredible document of some of the experiences of psychosis that people have. The game itself, which was released last year, ultimately produced a very, very positive outcome, with people, as well as winning multiple critical awards, it was widely discussed in terms of its ability to represent this previously neglected and, to some extent, highly stigmatized condition. It also furnished me with one of the most surreal experiences of my life, which was giving an acceptance speech for a BAFTA. And you see Tamim Antoniades, the creative director, who actually doesn't have enough arms to hold the BAFTAs that it won, because it won 5. Also, one of the proudest moments of my professional career was going along to the Royal College of Psychiatrists with Tamim and Dom from Ninja Theory, and also with the incredible people from Recovery College, Michael Lafond, Tracy Bartlett, Kathy Jones, and Jenny Essen, to receive an award from the college for its work in communicating. So this was about really mental illness, mental distress, but it's not always the case that visions occur in the context of the mind distressed. In 1760, Charles Bonnet described, based on his experience with his grandfather, who's suffering blindness as a consequence of corneal deterioration, the experience of seeing visions, of seeing buildings and birds and faces. And this description was the seminal one for Charles Bonnet syndrome, which occurs in the context of people losing their vision. Paradoxically, in losing their actual vision, they seem to experience hallucinations. And on the Charles Bonnet website, you can see some very, very powerful descriptions of the things people see. Big cats like tigers and panthers, sometimes inside the house, also outdoors. The images used to be scary, but now at least I can account for them. I often see miniature people moving from right to left. They wear strange outfits like the Oompa Loompas from Willy Wonka Chocolate Factory film. They seem to be busily going about their business. They never say anything, but sometimes they look straight at me, which can be a bit scary. Having had hallucinations such as a huge snake and a Chinese lady in full Chinese costume, I now know when I see things that aren't really there, they're all part of the syndrome. And this is critical. This is a situation in which those hallucinations are actually occurring in the context where the person knows that these are visions rather than reality, which distinguishes them from a lot of the other contexts in which you see them. Sometimes people can have an experience or an environment or some distressor that completely ruptures their sense of what is real, of what is trustworthy, of what they can rely upon. Trauma, torture, violence, neglect, abuse, many things can profoundly change one's perspective on what the reality of the world out there is and how one can apprehend it. I, like many psychiatrists, have many tales from people of the most horrendous experiences they've had, and also of the consequences of that, of the new prism through which they look at the world. And this can often include not just a changed understanding of that world, but a changed actual visual and auditory perception. Wilfred Owen, who, like Siegfried Sassoon, was a poet deeply traumatized in the First World War, put this more beautifully than I could with any of my descriptions. So I'm just going to show you a fragment of one of the poems that he wrote when he was inspired by the time in 1918 when he was an inpatient at Craig Lockhart with shell shock as a consequence of his traumas in the trenches. He called this mental cases. These are men whose minds the dead have ravished, memory fingers in their hair of murders, multitudinous murders they once witnessed. Wading sloughs of flesh these helpless wander, treading blood from lungs that had loved laughter. Always they must see these things and hear them. Always they must see these things and hear them. This really captures this notion of a profoundly changed experience of perceiving the world. I think it's also very telling and powerful that Wilfred Owen named this poem Mental Cases. He captures that dismissive attitude that presumably was the contemptuous term thrown at these people by their countrymen, by their officers, and maybe by their comrades in the trenches. And it also foreshadows what we still have today, the tendency to take these horrible inner turmoils and try to put them into simple descriptions and definitions which don't do them any justice at all. Donald Hebb, a famous psychologist, produced hallucinations in people in McGill in the 1950s by simply denuding them of sensory input. This was the onset of the sensory deprivation experiments. Within a short space of time of having your eyes covered, you can end up seeing things. Geometric patterns, flashes, faces, all sorts of things. And there's also the phenomenon of the prisoner's cinema, where somebody in solitary confinement in a darkened room will, within a short space of time, have a very cinematic experience of flashing lights and patterns and shapes in front of them. So far, I've discussed situations in which, by experiment or by illness, people have had a disrupted system producing hallucinations. But it's well known that actually hallucinations can be part of normal experience. There's a sort of dogma in psychiatry now that we're only just beginning to discover that everybody has some degree of hallucination. Actually, it's been known for 150 years and beyond. And Hippolyte Taine, the French psychiatrist, I think he was a psychiatrist, in his essay on intelligence, and I'm very grateful to my PhD student, Johanna Feynman, for directing me to his writing. He was so interested in the idea of normal hallucinations that he actually turned the situation on its head, and he said, external perception is an internal dream which proves to be in harmony with external things. And instead of calling hallucinations a false external perception, we must call external perception true hallucination. This is an idea that is currently echoed, you'll see it around a lot now, the idea that perception is a controlled hallucination, that the act of perception is one of hallucination. I don't fully buy into that, but as the second part of my talk will show you, I'm not a million miles away from it as an idea. Edmund Gurney and colleagues in the 1870s wrote a quite amazing treatise on hallucinations called Phantasms in the Living, in which they surveyed over 700 people. And they were well aware that hallucinations can occur in the absence of any sort of pathology. And by hallucinations, which I'm slowly switching over to using, I'm meaning perceiving an object in the absence of a shared external or agreed external reality, seeing something which isn't there. So this notion of hallucinations or visions occurring in normal circumstances really brings me to the second part of the talk, which is a necessary detour in which I conclude that the visual system creates perceptual experience based on what we already know. The problem is this: we all feel that we have a very direct contact with the world visually. We feel as though we're peering through windows onto this external reality and that we receive it very clearly. That's not the case. Vernon Mountcastle, the physiologist, made this very clear. He said we live within the prisons of our own brain, and that projecting from these brains are millions of fragile nerve endings that can sample the energetic states of the world, heat, light, force, chemical composition. But that's all we can know of that world directly. Everything else, he said, is pure inference. To put it another way, we have a sense of our brains being in contact with the world, but actually our brain is safely, warmly, snugly enclosed within the darkness of the skull. Now, luckily, the skull has got some holes in it, and through those holes, electrical signals can pass. And the job, if we're to apprehend the world outside, is to put those signals back together into an experience or an image or a perception or a belief about the world. And that's a real challenge, because actually we don't have much to go on in the visual system. We receive a narrow sliver of the electromagnetic spectrum. You know, there's an awful lot of information about reality out there that we don't get. Gamma rays, X-rays, infrared, ultraviolet, short and long radio waves. We can build machines that will get that, but we do not perceive that. What we've got to work on is this little narrow window of information. And that hits our retina at the back, and via a process of chemical and then electrical transduction, it can then be fed forward via bipolar cells through the ganglion cells and then into our optic nerve, and off it goes to the brain. So we really are out of touch with the world. There's an awful lot goes on between it and us. And the problem is that these inputs are intensive, they're ambiguous, they're often delayed. And the challenge is to somehow account for and deal with that problem. So how might we deal with the intensity of this incoming signal? One obvious way is to just ignore a lot of it. Just focus in on the salient, on the relevant. So here's a fairly busy image, and without any difficulties, most of you will, it's a toothpaste advert, most of you will probably zero in, even before I mentioned it, on the relevant part of this image. Similarly with this one, you'll zero in on that. And you do it quite easily and effortlessly. But you pay a price for that. And I'm sure some of you will have spotted the price that you pay having seen this before. You might have missed the fact that this woman's quite well blessed for fingers. Or that there's a phantom arm here. you miss a lot in focusing in on what's salient. And one of my heroes, Horace Barlow, who actually is the great-grandson of Darwin, I'm told, and who's still active in Cambridge in his late 90s, he wrote some brilliant work on this in the 1950s and 60s. And one point that he made that I think is very important is that what we try and do in perceiving the world is just allow to pass on what's the news, what's the relevant stuff. Not everything, but remove the redundancy, focus on the relevant. And he appealed to the by then established field of information theory and work of Donald Mackay, who suggested that perception, the correlate of perception, entails an outwardly directed internal matching signal and an input from the receptors. Now, I'm going to unpack that a little now. I just want you to hold on to that idea. From my point of view, part of Barlow's genius was relating visual perception to information theory. And as I said, it was an established field by then. The seminal paper by Claude Shannon on a mathematical theory of communication had been written in 1948. What Barlow recognized, and others were recognizing, is that the problems of communication, of sending messages electrically, were very similar to the problems of perception. We have a highly intense, noisy, ambiguous signal that's being transmitted on a limited capacity system needing to be decoded. And pointing that out, I think, has been very powerful in our thinking. So we can appeal to information theory and look at things like telecommunication. This is a paper by Harrison in 1952. And Harrison was concerned primarily with how we might transmit pictures on television and how we might do so within a limited system. And of course, one thing you could do here is you could move from left to right, top to bottom, and simply transmit the signal intensity from each pixel along the wire and then rebuild the picture at the other end. You'd have a very, very boring television program if you did that, because it would be so slow. What Harrison acknowledged and recognized is actually there's an awful lot of redundancy here and a lot of predictability. So any given pixel is highly predicted by the pixels around it. You could go into there, pick out one, and you pretty much know what it was by looking at the areas around it. And what he suggested was that what you transmit forward is not the actual signal itself, but how any given region differs from the regions around it. And if you do that based on simple linear prediction, you can really retain the salient features of the image without any great loss. And then you can recompile it at the other end. Just to unpack that slightly, so the idea is that prediction, more or less, or more specifically, deviation from prediction error, offers a means to pass on the newsworthy information effectively and efficiently in a limited capacity system. It's not the absolute signal, but the mismatch that's really key. And importantly, visual signals, the ones we're getting, they lend themselves to this sort of prediction, both in terms of their spatial array and in terms of the timing. And there's something very, very beautiful here, which is the structure of the retina seems to lend itself to that sort of so-called predictive coding. This was brilliant work done by Srinivasan in 1982, and colleagues, I should say. And the idea is that these cells, the rods and cones, are activated by the light. They pass on their activation via the bipolar cells to the ganglion cells to the optic nerve. But critically, each of them is joined up by these horizontal cells. And the horizontal cells means that the activity in any given region also suppresses activity in its neighbors. So every cell is shouting its activity, but being shouted down by its neighbors. And what this will actually do is it will favor those cells that differ from their neighbors. The cells with similar activity will cancel each other out. The cells that differ will stand out, and it's the newsworthy signals that survive and then percolate forward. Now, this is not a done deal, this is not proven, but there's something very beautiful about that aspect of the design of the retina that suggests from the very earliest stages of light hitting us, we are already processing it. And this predictability also occurs across time. If you were to watch this scene unfold as this great ship moves across the horizon, there's a huge amount of it would be highly predictable. Not much is changing. You'd only really have to keep an eye on this bit. I mean, there'd be obviously clouds changing and a few ripples. And even this would be progressing in a very predictable way. And again, we can capitalize on that predictability in order to reduce the redundancy and make ourselves efficient. I've borrowed here an analogy taken from Dr. David Cox from Harvard. He gives a brilliant lecture on YouTube, quite a technical one, but a brilliant one on predictive coding and perception. And he uses the idea of Serena Williams. Now imagine you're facing a serve from Serena Williams. She's going to hit that ball at over 200 kilometers an hour. So it'll take, from it to leave her racket and hit your face, it's going to take about 400 milliseconds. Now the light from the ball will travel from your retina to your primary visual cortex in about 60 milliseconds. And it'll reach the sort of higher order visual areas, which you would claim you need to be able to perceive things, in about 170 milliseconds. So actually, what you're sensing is about 9 meters behind where the ball actually is, which is bad news if you want to try and return Serena's serve. Now, the suggestion is that we actually make predictions, and we act on perception as a prediction rather than just waiting for the sensations to arise. The idea, I think, is that sensation is history, perception is clairvoyance. Now, I'm not sure if this will work, but I'm going to try and convince you that that's the case. So if we have a highly predictable stimulus here, which is simply a bar rotating at a constant rate, then we can perceive that without any difficulties. Now, I would argue that actually what you're perceiving is a projection into the future rather than what your senses are actually telling you. If I show another bar rotating, and this time extend it periodically in an unpredictable way, then you should see that lag behind, because the unpredictable bar, you can't use prediction. You don't have the capacity to use this clairvoyance. You have to rely on senses. So even though the bar is actually dead in line with the center bar, which you can predict, theoretically it should feel, and it is a subtle effect, that it's lagging slightly. I'm not sure if you're convinced by that, but I'm going to pretend that you are, just for my own peace of mind. So this idea of prediction-based processing helps us deal with the intensity and with the delay. It's a really fantastic system, potentially. What about the ambiguity? What is the ambiguity? Well, all of our incoming signals are inherently carrying an ambiguity. As soon as you compress a three-dimensional image onto the flat surface of the retina, you're immediately changing the information, and it's an inverse problem to imagine what three-dimensional object could have given to that two-dimensional rendering. Put more simply, you can take something like a bottle of water, and you don't know if it's a very, very tiny one that's very close to you or a very, very big one that's very far away. And so people have a lot of fun playing with these perspectives and creating illusions. But of course, we don't really have that problem day to day. I mean, all the time, we don't think, oh, I wonder if that's a very big bottle that's very far away. We just reach out, we know where it is. And the reason that we can do that is that a profound insight, I think, of Claude Shannon's, which is that the information in that signal relates not just to the uncertainty or predictability of the signal, but to what the expectations of the recipient are. And this seems to me a really key insight to understanding how we can apprehend the world. We don't need much prior knowledge about things or much information to know when to act quickly. It's just a little bit of extra information that can be enough to profoundly change our apprehension of the world. And we can link these ideas to biology. There's been a cottage industry since the early 90s thinking about the brain as a predictive organ. And this does go back much earlier than that, I should add. So Rao and Ballard in 1999, there's also a very, very powerful paper by Mumford in 1992, referred to this idea of predictive coding in the visual cortex. And essentially they hypothesized, and this is schematic and simple, but it sort of works to take us forward, that we have these higher order areas that are channeling down their predictions to the lower order areas which are receiving the input. And what happens is that what's computed is the difference between what is predicted and what is input. And what's fed forward is that computation, that prediction error. So we're back to this idea that it's prediction error that carries the key information, prediction error that's newsworthy signal. And they came up with a nice little schematic, which always makes it feel a bit more biological. So you put the input in, you've got the prediction, there's a mismatch, the error signal is fed forward, the prediction is updated, but also that's being predicted by higher order predictors. And again, there are error signals percolating up, and predictions percolating down, and the aim of the system is to come to some sort of overall agreement. So in short, and to put that into the sort of simple terms that appeal to me, we don't passively receive data from the world. What we know and expect governs what we see and how we see it. And prediction-based perception, and critically a sensitivity to prediction errors, confers a very powerful means of dealing with complex and coded signals. In other words, perception is a process not of reception, but of inference, and what's been referred to as abductive inference, reasoning backwards from the data you have to what you think might have caused those data. Now, my colleague Christoph Teufel and I have got very, very interested in using stimuli such as these to try and test those ideas. I just want to briefly run you through these and give you an example of an experiment that we can use to test this idea of higher order predictions governing what happens in lower order processing areas. So to many of you, this will seem like a very noisy black and white blob collection with no real meaning. Some of you will have seen it before, and you'll see that there's actually a lady in it, and she's kissing a horse. And the reason you know it is because you've seen this image before. Now, if you see these things a few times, it becomes possible to pick out the salient features. Critically, before you know this and after you know this image itself, the input hasn't changed. What's changed is your higher order knowledge, and we wanted to capitalize on that experimentally. Here's another example. I'm imagining nobody can really pick this out. It's a climber. Difficult to see even when you know, but nonetheless, that suits our experimental purposes. So what Christoph and I got very excited about, we are very easily excited in neurobiology, was that there are some areas of this image that seem to take on a life of their own when you have this prior knowledge. So there's an area of the woman's jawline here that physically simply isn't there, but when you know this image well, you sort of start to see it. You start to, hesitate to say, perceive it in the absence of an objective stimuli or hallucinate it. And Christoph became very interested in what is actually happening to the lower level processing as a function of that top-down experience or knowledge. And so he came up with a clever idea of testing it. He placed upon these areas certain types of stimuli. Now, I've made this very clear that there's a little edge embedded in that patch there. But in reality, this was something very, very subtle, very difficult to see. And he was adjusting the intensity so that he could find the person's threshold for perceiving it. And the critical question was the threshold changed depending on whether you knew there should be a contour there, before versus after your having seen the template image? And the control stimuli were ones that weren't aligned with the invisible contour. So just to take you through that, you've got a before phase where you've just got the input, no real predictions or expectations about it. You've then got the clear template image, which confers this knowledge that then allows you to, if you like, engage in a top-down processing. And then there's the after. Does the sensitivity change from before to after? And sure enough, what he found was that if the very low-level contour was aligned with the invisible contour, then moving from before to after, your sensitivity increased. But that didn't work if it wasn't aligned. What this suggests is that these higher-level knowledge that you can gain by showing someone a picture fundamentally changes very low-level visual processing, exactly in keeping with this predictive coding model. So to summarize this part, predictions based on these spatial and temporal correlations, as well as our past experience and our knowledge, which of course is what's embedded in our brain's model, can enhance the sensitivity, enhance the efficiency, improve the sensitivity, and help us deal with this intensive and very ambiguous signal. This is a great way to go about things. What a fantastic system. And there's always a but. And the but is what I deal with in the third part of this talk. Is normal vision therefore hallucinatory to some extent? What are the vulnerabilities in this sort of system? Well, if we look at a classic perceptual illusion, the so-called Koenigsegg triangle, it's very difficult not to see this as some sort of hallucination, to see a phantom white triangle, even though objectively there is no contour there. Your mind just seems to fill it in. It's hard not to see it because of the arrangement behind. Now, this is referred to as an illusion, and I was taught as a training junior that illusions are very different to hallucinations because illusions are misperceptions of reality, hallucinations are perceptions when there is no reality. I rather like Edmund Gurney from the 1870s take on it. He saw then that illusions were actually a sprinkling of fragments of hallucination on true perception. And I think that perfectly describes this. I think there's a sprinkling of fragment of hallucination. Another phenomenon that really is telling us important information about what we're doing to visual stimuli is the so-called binocular rivalry phenomenon. If I show a different picture to each of your eyes, I set up a particular set of apparatus, stereoscopic apparatus, and I show one of your eyes a face and one of your eyes a house, then what you might imagine would happen is that in the brain it all gets mixed up and you've got a sort of facey-housey or a housey-facey type image. But that's not what happens. What happens is that you either see a house or a face, and that changes from one to the other. It's sort of periodically a face will move into a house or a house into a face. And the suggestion is that's because it's so unlikely, it's so out of keeping with your prior knowledge that a face and a house should occupy the same space, that you simply can't, your brain simply cannot allow that to be the perception. Now you might argue that actually it's just one eye's dominant and then the other eye's dominant and then you move back. But actually if you do something different, you put half a face and half a house to this eye and the other half of the house and the other half of the face to that eye, the perception is still of a face or a house. So you're putting it back together in a way that best makes sense with what you know about how the world works and how it's put together. Interestingly, you can add another top-down level. There's a very interesting experiment by Zhu and colleagues in 2010. I don't know if it was replicated, but they showed pictures. They showed one eye a marker pen and another eye, the other eye of a person, a rose. And they pervaded the air with either the smell of marker pens or the smell of roses. And what they found was that if you were smelling roses, you were more likely to see roses. So this is a sort of two-layer of prediction, creating the percept that you're allowed to see. Another very famous illusion, or possibly hallucination, that was brought out by Richard Gregory is the so-called hollow mask illusion. And the idea behind this is that we all know about faces. We know a great deal about them. We have particular brain regions that process faces. And one thing we know about faces is that they stick out. They're convex. They're not concave. So if you have this hollow mask, as the features become available and you can detect that it's a face, it's very difficult not to see it as a face that's sticking out rather than a concave one. Again, it's a suggestion that what you already know, what you predict, is fundamentally determining how you perceive the world. This handsome devil is Ivan Muzhukin, a 1920s matinee idol in Russia. Kulyeshov, who was a film director, interspersed clips of Muzhukin emoting to the camera with other clips of film. One of the clips was of a dead body, one was of a delicious meal, and one was a very attractive woman. The audience who saw these interspersed clips were very complimentary about Muzhukin's ability to portray in his facial expression either deep grief or intense hunger or a profound lust. What they didn't know was that each clip of Muzhukin was the same, and the emotion itself was actually lying in how they were perceiving him rather than in objective differences in the film of him. So how they interpreted his facial expression depended upon what they thought he was looking at. So we all pride ourselves on being able to read people's faces. It's much more about what's in here than what's actually out there, what we think about them and what we think about what they're thinking. That profoundly changes our perception. So I said at the start of this that there is a but, and I think we can summarize the but to say that there are strong expectations that can create perceptions. Created perceptions, that's hallucinations. They may overwrite the actual data that are there, and the system readily deviates from an objective reality. So in the last part, I just want to unpack that and reapply it to the idea of hallucinatory phenomena. And I've come up with this schematic, which at the time seemed a great idea. If anyone can explain it to me, I'd be very grateful. The idea that I wanted to convey, this is actually really just a version of the Rao and Ballard schematic that I gave. The idea is that you have an input, a visual input, and that's interacting with these downcoming predictions and achieving a balance. with any mismatch between the two being percolated forward as a prediction error to the next level, and that going on. So the idea is that we have a system that's balancing what we expect, what our predictions are, with what the input is. The overall aim of this system is really to try and keep those pesky prediction errors down, because prediction errors signal uncertainty, and brains are completely allergic to uncertainty. So the idea is to modulate the predictions, modulate how you're interpreting the input to somehow be a system in balance. The idea that's an extension of that is that predictions at these lower levels of the system are more concrete and specific and physical, whereas the predictions at the upper level are more complex, abstract, general, possibly social. So an idea might be that at this level we've got the predictions about the nature of faces. Is it a face? How is it aligned? Maybe at an intermediate level it's about the gender or the identity. And at the highest levels it's about predictions about the nature of the facial expression. Is this a trustworthy person? Is this a person who likes me or dislikes me? That's, I'm being deliberately simplistic here to try and just unpack the ideas. So if this is a system in balance, we can now begin to look at it and think, what would throw it out of balance? And of course, although these are just non-biological schematics, we would know that the downward-coming predictions and the upward-going prediction errors are necessarily mediated by neurochemicals. And so we can make predictions based upon neurochemical properties of neurotransmitters. What sort of perturbations could shift the balance, whether it's serotonergic perturbation through LSD, glutamate perturbation through ketamine, alcohol. We saw that the withdrawal from alcohol from Dickens and Zola produces a really profound shifting of the system. We can also speculate on the nature of the connections and how they might change. But I just want to focus on two possible thought experiments about how we might explain hallucinations in this system. So imagine we simply denude the person of their visual input. We cover their eyes, or they're going blind, and therefore the input is actually becoming less and less. What this would immediately create is an imbalance, such that all the weighting went towards the predictions rather than the input. This would lead you to be actually much of the feed-forward signal being the creation of your own mind rather than reflecting what was out there in reality, which is sort of what happens with Charles Bonnet syndrome and with sensory deprivation. Also, since these higher levels are not actually impaired, it's entirely possible that one could retain insight and at the higher levels recognize that what's going down below is not a true reflection of reality, which is what we find with sensory deprivation and Charles Bonnet syndrome. What about if we perturb the system at a much higher level? What about if somebody undergoes some horrific experience that profoundly disrupts their expectation of the world? What if it's a long experienced abuse or neglect at an early age where they're forming their expectation, where their mind's at its most malleable? Well, then you have a high-level set of priors that the world is not a nice place, that people are not to be trusted, that people are potentially violent. And all of this will percolate down to fundamentally change the way in which you make predictions about stimuli. It might change the way in which you predict or experience facial expressions, as we saw with the Kuleshov film experiment. And it might go down even further. You might even begin to see harm in non-social situations. You might see faces in clouds. You might see all sorts of subtle changes in how you perceive the world. This is just me having fun, waving my arms and trying to put things together to explain it. There's a huge amount of experimental work that needs to be done. Fortunately, there are some very clever people around who've begun that enterprise, much cleverer than I am, I'm happy to say. Chris Frith, a former mentor of mine, has done a huge amount of work in this area. Carl Friston has really draped this in very elegant mathematics, which I won't pretend to understand. Peggy Series in Edinburgh is doing brilliant work, and Sophie Deneve and her colleague Renaud Jardry in Paris are taking a slightly different model and really putting it through its paces experimentally and theoretically. Some very exciting work going on. For those who are interested in reading more, and at the risk of being self-aggrandizing, I was fortunate enough to write with Chris Frith a paper a decade ago now, in which we were attempting to lay out these ideas, or at least some of the embryonic ideas, in a sort of clear and readable form. So if you do want to read more, you might want to try this one out. It's possible to begin to collect data that by indirections comes at these sorts of hypotheses. So work that my PhD student Phil Corlett and my colleague Graham Murray did has looked at how the brain signal changes as a function of whether something is predicted or not. So this is getting at the idea of brain responses to this key signal prediction error. And in our healthy control subjects, we can see that certain regions, in this case the frontal lobe, are very sensitive to surprising events compared to non-surprising events. And if you take individuals who have suffered from an illness that entails hallucinations, they seem to have a very different response, as though the brain is not distinguishing between what should be surprising and what shouldn't. We can also give our healthy controls drugs that will produce a transient psychotic state, including hallucinations. And we find a very comparable picture in that brain region. We see that on placebo, there's a retained sensitivity to this difference, but on drug, there's a pattern that's very like in our individuals who suffer from psychosis. And it wouldn't do to move on without mentioning some of the really incredible work that people like Guillermo Horger in Columbia, New York, and Katarina Schmack now in Cold Spring Harbor. And my colleague, he was my first PhD student actually, but seems to have survived the experience and is now thriving in Yale. But I want to finish on one experiment that I really enjoyed doing with my colleague Christoph Teufel. And this involved a very simple experimental prediction, testing a very simple hypothesis using our favorite stimuli. And the question here was, to me a very interesting one, if it's truly the case that we can consider visions or hallucinations as being a consequence of the system being too far in favor of prediction and not enough in favor of input, in other words, the prediction is creating the experience irrespective of the input, then it should be possible to use an experiment like this to test the amount of prediction people are using and to compare that between people who are prone to hallucinations and people who aren't. So Christoph showed individuals these stimuli both before and after they'd seen the template. And the question was simply, can you see a figure in this image? So we had lots and lots of different images. At the beginning, of course, they struggled because they had no prior knowledge. Afterwards, they got much better because they now had prior knowledge. And the prediction was that if you were hallucination prone, we're really capitalizing on your skills here because you should be able to use this information even more powerfully afterwards. And what he found was, if we look at our controls, before they've seen this template there, this is a really measure of their ability to perceive. They're at a certain level that goes up as a consequence of the prior knowledge. No surprises. In our hallucination-prone people, they show a much more significant, or a much greater, a more significant increase in their ability to perform this task. So what in some circumstances might be considered disadvantageous, a tendency to superimpose predictions on input data, in this case, is actually advantageous. So, I want to draw to a conclusion now. So, I'm going to summarize everything I've said over the last 55 minutes in 4 lines. So, visual perception is not a process of passive viewing. It's one of inference and ultimately creativity. The visual system, I think, in the way it's set up, right from the very first point at the retina, it confers a ready-made tendency to see what is not there or to process signals in a way that divorces them from their original form. And it confers the same ready-made tendency to bend perception of what is there according to our expectations. Think of Ivan Mazhukin's facial expression. Think of the binocular rivalry. Think of the Kanitsa triangle. I think this is incredibly useful. In fact, I think it's one of the only ways we could get by with these highly denuded, but at the same time very intense, ambiguous, noisy, delayed signals. But it demands a fine degree of balance, and that balance can be shifted by many factors. Those may be pathological, as in neurochemical disruptions, as in profoundly debilitating traumas and experiences, as in the loss of sight, as in taking drugs, withdrawing from alcohol. They can also be non-pathological. Stress is one great example of how our perceptions can be fundamentally changed. Think of walking down a dark alley at night. One's tendency to perception of shadows and things is profoundly changed by the fact that the system's set at a different pitch. It's calibrated differently by the experience of stress. Stress also tends to make people see patterns that aren't actually there. They did a very interesting experiment on people just before and after a skydiving experience. And they showed that just before the experience, your tendency to see patterns in what were actually random arrays of dots was much enhanced. So it doesn't necessarily entail pathology, is what I'm saying. I suppose the ultimate question of this work is, well, so what? You know, it's all very interesting. I mean, is it any use to anybody? I think it's important. I think understanding mechanisms is a critical stage to inspiring or refining the interventions or treatments or ways of helping people. Now, many people would dismiss that and say that a lot of psychiatry is serendipitous. The drugs that we found have been found by accident, as with much of medicine. Ultimately, I still hold to the idea that understanding mechanisms is a key first stage. And I think it can be helpful at a personal level. I mean, we saw the self-reports of people with Charles Bonnet syndrome. To be able to explain to people why these mysterious apparitions are occurring is very, very important and useful to them. It can inform cognitive and behavioral and possibly pharmacological interventions. That's slightly hand-wavy. We still don't know how, but I think it's an important point. But secondly, I think that understanding the mechanisms really encourages and supports richer research and communication. My fervent hope is that this sort of work can at least play a small part in taking psychiatry beyond the really arid and fruitless and often angry debate about causes of psychological illness and distress. You know, is it the brain, or is it the psychology, the cognitive processes, or is it the social factors? Clearly, all of those have a huge impact on the generation of psychiatric illness, psychiatric distress, and also on its manifestation. But to say that, or to assume that we can understand the processes of the brain without taking great account of the context within which that brain is operating and of which it must be trying to make sense and to model, seems to me arrogant. And at the other end, to suggest that we can understand the impact of social factors without thinking carefully about the apparatus that processes those factors, the brain and the system, sensory systems, is equally misguided. So I do think that taking a multi-level approach and seeking ways of joining them together is critical. Also, I think all of us are really in the business of trying to make sense of a horribly mysterious and noisy world. And we're pattern seekers and model builders. And we define ourselves according to the models that we build and the patterns that we share with each other. And we define our place in culture and society by that. To have a model that is not shared, to have a reality that is unshared, is a deeply distressing and isolating experience. And I think a critical part of trying to mitigate that and to destigmatize is to really try and understand the processes. One of my most treasured letters over the last couple of years, and this is the slide I'll finish on, came from a young woman who played the game Hellblade. Now, I had several messages like this, and I know that the Ninja Theory team had hundreds. And for me, what this was essentially underlining, and I'll leave you to read it, was that the mere act of trying to understand something in order to represent and communicate it can play a huge part in not mitigating it, but to some extent showing people that this is not some bizarre, incomprehensible problem. And I think that's very important indeed. It may not be a spanking new treatment or a new technology or a new clever diagnostic system, but the mere act of representing and communicating things like visions ultimately is important. And on that note, and with those words, I'd like to thank you very much for listening to me.
Thank you very much indeed. I mean, I think you've brought us some fascinating insights into what I term the mind's eye, how our brains construct our experience of the world, what we regard as normal, the extent to which that's factually correct or not, and how it might or might not relate to reality, and then how alternative realities arise. There's a huge amount to think about it. I mean, I guess, I know I can touch the edge of this table. I know where it is. I haven't got a bottle of water there that might be regular size or giant over there. I'm relieved at that. But I guess if you're a fish in the ocean and you're watching for sharks, if you have a false positive, that's fine. That doesn't really matter. But if you've got a false negative, that's the end of you. So maybe that's how all of this systeming and signaling starts to evolve. I don't know. We can obviously talk for ages later. But thank you very much indeed. So to come to the end of this week's lecture, for next week, second lecture in this series is entitled Colour and Vision. And Professor Anja Hurlbert, the director of the Centre for Translational Systems Neuroscience at Newcastle, is going to talk about how our brains create colour, why colour is subjective, and why it's such an emotive aspect of appreciation and of art. So that's next week, same time, same place. Hope to see you then. But finally, Paul, thank you very much indeed again.